Okay, this is a problem where you need to actually write the equation first. So this is a skill you absolutely will need to develop because um, if you think about the purpose of mathematics, it's not to simply solve problems that someone else already gave you, but to encounter real life situations and figure out a way to um, create some mathematical equation that you need to then solve to find out the information you want. So you can, uh, you know, treat real life situations as potential mathematical situations. And here's a good example. Okay, maximum capacity. You should know that elevators can only hold up to a certain amount, and you can't exceed that amount. Just you don't want to crash the elevator. So a delivery person uses a service elevator to bring boxes of books up to an office. The delivery person weighs 160 pounds, and each box of books weighs 50 pounds. Now, the maximum capacity of the elevator is 1,000 pounds. How many boxes of books can the delivery person bring up at one time? So let's first think about this. Um, we know that the weight that we come up with is going to be equal to 1,000. So on one side, it's going to say equals 1,000. Now, where do we get that 1,000 pounds from? Well, you get it from the 160 pounds that the person weighs, and you're only going to have that once because there's one delivery person. But then there's multiple boxes, and they each weigh 50 pounds. So you can say that you've got 160 for the person plus 50 pounds times however many of those boxes there are, because if you had one box of books, 50 times one is 50 pounds total for the books. But if you had two boxes of books, you'd have 50 times two boxes for 100 pounds for the weight of the books, and so on. Three boxes would be 50 times three. So you don't know how many boxes you can bring. That's the idea. So we're going to define the variable b as, and let me write that down. I didn't write this, but I'm going to do it now. Okay. Let me say here at the top. Okay, and I apologize because I didn't realize that I should do that first. Okay, so we can say let b equal the number of boxes of books. Okay, and that's that you're bringing onto the elevator at any one time. Okay, let b equal the number of boxes of books. So now let's take a look at what we've got. Okay, put that up there. What we've got now is this. We've got 160 for the weight of the person, and then plus 50 times however many boxes we have. 50 times 1 for one box would be 50 pounds in books. 50 times 2, 100 pounds of books, etc. Okay, and we know that that can equal 1,000. So we have this set up, and we say, okay, what are we going to do to solve this to find out what's the maximum number of books we can bring? Well, first let's just see what solves this, what value of b solves this to equal exactly 1,000. Okay, and what we need to do is we need to subtract away this 160 from both sides. So you can see me here, I've skipped a line, and then I've rewritten the original equation, or the original expression from the left side, 160 plus 50b, and I'm taking away that 160, minus 160. Okay, those two will cancel out. And if I do it to one side, I have to do it to the other, so I have to write the original expression, 1,000, and then minus 160 from both sides. Minus 160 and minus 160 is how I changed it, each side. Now, simplifying that, the 160s cancel out to leave you just 50b, and 1,000 minus 160 is 840. That might be a little bit of math problem that you do over on the side, and I'm going to talk about what that is going to look like in a minute for some of these, but I can do this in my head because 1,000 minus 100, that's 900, and then 900 minus another 60 is 840. So we've got 50 times b equals 840. Now if we wanted to solve for that, what would we do? We divide by the coefficients. We're going to divide, oops, sorry about that. We're going to divide 50b by 50 and 840 by 50 as well. Okay, now that'll turn this into 50 over 50 or 1b, which equals just b. And if we divide this, we find that it is 16.8. Okay, now how did we know that? Well, this is how we know it. We're going to take this math problem right here, 840 divided by 50, and I'm going to rewrite it here. Okay, I'm going to move this up for a minute so you can just see the math that I do, and then I'll move it back down. Okay, so fun fact, if we wanted to have a simpler math problem that would give us the same answer, we can say we're going to cancel out, we're going to divide both of these by 10, leaving us with the equivalent division problem of 84 divided by 5. Okay, now zoom in on that. Let's solve this. Okay, 84 divided by 5. Well, 5 goes into 8 one time. Take away that 5, you're left with a 3. Bring down the 4. Every time you bring a number down, you got to put a number up. And 5 goes into 34 6 times. That's 30. Now, continuing on, we've got 4 left over. And what can we do now? There's no numbers to bring down, but we are allowed to put a decimal at the end of this. We can say 84.0 is the same as 84. Now there's a digit to bring down. And how many times does 5 go into 40? It goes in 8 times. And 5 times 8 is 40. So we subtract away the 40, and now we're left with nothing. So we get 16.8. Okay? And that's where I came up with 16.8. Right here. Okay, I divided this and I got this. Now let's box that answer. Okay, and now we're going to do our proof for this. So the proof says, let's start with the original equation. Right, and the original equation that we wrote was 160, the weight of the delivery person, plus 50 times B, the weight of the B number of boxes of books, and that can equal 1,000. So what do we do? Well, we're going to do a proof. So what we do for a proof is we just substitute in the value. So we say 160 plus 50 times, see what we boxed over here, B is equal to 16.8. So we plug in 16.8 for B equals 1,000. And when we simplify that, we get 50 times 16.8 is 840. Okay? And I'll do that math down in the bottom in a second, just so you can verify it. But I know that that's true because I already did it. Now, 160 plus 840, let's think about this a second. What's 840 plus another 100? That's 940. So what's 940 plus the other 60? That's 1,000 exactly. Okay, so that simplifies to 1,000 equals 1,000, and check that that works. We can check, put a check mark, it works. Okay, now let's do this math down here. I'm just going to move this up and let you see the math. If you do 16.8 times 50, you say 0 times 8 is 0. And in fact, if we did 0 times 6, we'd get 0. 0 times 1, we'd get 0. And that just gives us a bunch of zeros. So when we're adding, remember the identity property of addition. If you add 0, it doesn't change it. So I'm not actually going to do this step. We don't need that. We know that the 0 is going to just result in a bunch of zeros, and it's the 0 property of multiplication as well, right? Because first of all, we say 0 times 8, 0. 0 times 6, 0. 0 times 1, 0. That's the 0 property of multiplication. You'll get 0 every time you multiply by 0. So having a string of zeros here, when added to whatever we get on the second line, would result in not changing the second line because you're adding 0, and that doesn't add anything to the total. So this is how we skip that line. We just say, okay, let's just go straight to multiplying by the 5. Well, if we're going to multiply by the 5, we need to say the first digit from the 5 needs to come straight down, and so we need something here to hold that number into place. And what do we put there? We put 0 there. Okay? So now we say 5 times 8, that's 40. Carry the 4. 5 times 6 is 30, plus 4 is 34. So we put the 4, carry the 3, and now we do 5 times 1 is 5, plus 3 more, 6, 7, 8. And where do we put the final decimal in the answer? Well, the rule is to say, looking at the original problem, how many digits were behind a decimal? And we see just the single 8 was behind the decimal. So we have a single digit behind the decimal in the answer. And when you get 840.0, that's the same as 840. And so when we look back again, we say, oh, right, when we did 50 times 16.8, that was this. That became 840, and that's why we have the 840 there. All of this math in red, you should do off to the side somewhere else. What you need to see, what I need to see very clearly, is all of this math as neatly and clearly as you're seeing it from me right now. Okay? These calculations, you're going to need to know how to do them, and you really should be using the lines just like I did. See how I kept those neat too? Because the math should stay nice and neat, no matter what kind of math you're doing. But there you get your answer. So this is not the final answer, of course, because what they're really asking us, and let's read what it says, how many boxes of books can the delivery person bring up at any one time? And if the very, very maximum that they could bring up to hit 1,000 pounds exactly, which is what we calculated, is 16.8, then we have to decide if they can only bring a whole number of boxes, either 16 or 17. What would happen if they exceeded this number and they did 17? Well, as you can see, 16.8 results in 1,000 exactly. Going above this number is going to go above 1,000. Remember, we can't make the elevator's weight go above 1,000, or it either won't go or it maybe will crash. So if we have to pick a whole number, we can't pick 17, so we need to round down and say 16 boxes. Okay, so then the answer becomes 16 boxes. That, my friends, is the final answer, because that's what they ultimately were asking up top here. How many boxes of books can the delivery person bring up at any one time? And since they can only bring full boxes, 16 boxes is the most. 17 would tip you over into more than 1,000 pounds, which is not okay with the elevator.